Now, there is one more thing we want to talk about here. A different kind of asymptote that is not horizontal or vertical. So if you want to get fancy about it, you could call it oblique. So just some other line whose slope is not 0 and whose slope is not vertical either. So we don't have an undefined slope. Now, technically what's going on is that in the limit, as x goes to infinity, the value of our function f of x is going to get closer to the value of this linear formula, mx plus b. And if this limit is equal to 0, then we'll say that the function f of x has this slant asymptote. So here in the picture is an example of a function where if I look at x equals 0, the function is kind of far away from this line. As I go out further, the function gets closer to that line. So these are easiest to find for rational functions. How do I know I have a slant asymptote of a rational function? That will show up if the numerator has degree exactly 1 more than the degree of the denominator, right? So if I think about this as, that numerator will be kind of like its largest exponent on top, whatever x to the n is on top. It'll be kind of like whatever its largest exponent on the bottom is. So in the long term, it'll look pretty much like a linear function. So let's take a different rational function as an example here. My function is f of x equals x cubed divided by x squared plus 1. Now this function is actually defined for all values of x. There are no interruptions in the domain. It'll work for all real numbers x. Once again, my y-intercept is going to be at y equals 0, but then x also has to be equal to 0. So this function will touch the origin. Is this function even or odd? If I plug in a negative x, my numerator will be negative x cubed, right? Since if I cube a negative number, it remains negative. On the denominator, the square of negative x is x squared, which is always positive. So put those together, and this function is an odd function. So odd symmetry says that we don't just mirror across the x-axis, we actually rotate the whole graph 180 degrees to get our symmetry. Just like the sine function, or just like the cube function. Now, since I don't have any interruptions in this domain, f of x is nice and continuous, defined for all real numbers. There will be no vertical asymptotes. And I'm going to check for horizontal asymptotes as well. Take the limit as x goes to infinity. My numerator, x cubed, is going to grow much faster than my denominator, x squared, is. So in the limit, this will grow unboundedly. We'll go to positive infinity or to negative infinity, depending on whether you're going in the positive x direction or the negative x direction. Now, what about this slant asymptote business? I was saying before that we want a rational function whose degree of the numerator is 1 more than the degree of the denominator, which is exactly what this function has. So if I try long division on this, I can rewrite the formula as x, just an x, minus x divided by x squared plus 1. So in the limit, as x goes to infinity, this x here on it by itself is what's making the function go to infinity. And then this x on x squared plus 1 is going to 0. So all the interesting stuff is happening for this main term here, this x by itself. So what would my slant asymptote be? Well, f of x minus x, right? So this might be the formula for my line, is equal to negative x on x squared plus 1. If I take a limit of this difference as x goes to infinity, that's going to go to 0, either as x goes to positive infinity or x goes to negative infinity. So this function will have a slant asymptote for the line y equals x. Now let's see that. Here is my picture of the slant asymptote. I've gone ahead and added in some concavity information as well. But notice that the further out I go to the left or to the right, the function is getting closer to this line with slope equal to 1. So how do I know there should be a slant asymptote there? The degree of the numerator is 1 more than the degree of the denominator. How do I know what slope that should be? The slope is the leading coefficient of the numerator, which is 1, divided by the leading coefficient of the denominator, which is also 1. So 1 over 1, that's slope